That's great. Well, thank you, everybody. Thanks for joining us. This is awesome. I love these hot seats. Every month we have Ideal Networks. Been hearing a lot about these guys, and we have some ambassadors and directors that absolutely love their products. I've been getting to know the CEO. I've been getting to know Dan and Wendy. A bunch of people reached out to me, and I've been going back and forth with them. And it's a really cool company, and they make some really cool products. Really excited to dive in. I know that Chris Tiffany, he's one of our directors. He's not in the chat right now, but I do want to get his feedback. If anybody sees Chris Tiffany pop in, he's a big supporter of Ideal Networks. If anybody sees him pop in, let me know. I'm going to get a brief little summary from him. But yeah, so Dan, if you're ready to go ahead and present, I'd love to hear what you have to say about it.
Thanks. Thanks for having Wendy and me. So I'll give you guys a little overview of Ideal real quick, and then I've got 3 topics to discuss with you that are kind of things that have come up in standards and testing over the last months. Then we'll have some Q&A. I like going technical, so Wendy's here to pull me out in case I start getting too deep, and I don't want to, put people to sleep here, but I do encourage any questions you have. So there's, you can put a question in the Q&A or raise your hand or whatever, and we'll take those as they come. And there's also, of course, Q&A at the end. So Ideal Networks, you can see we have a pretty broad range of products here. We focus on physical layer testing of copper and fiber, and also network testing up to layer 2, 3, and 4 for some of our products. And I'm a little disappointed today because we have a brand new product I'll talk a little bit about. And it's by brand new, I mean the first production batch is getting ready to ship. And I was supposed to have one here for this live demo today, but it didn't show up. So Wendy's got we have like a virtual online kind of a demo that we'll run through just to give you guys some other ways to test besides using certifiers. The products that we have start from verifiers, which are the little guys on the right side with the small blue screen there, and that's your wire map checker. We have one that does PoE, so for full PoE testing, which I'll talk about in the one of the slides here in detail. But and then Signal Tech, which is a transmission tester. So the new one that we've just launched is a 10 gig version of that. And then of course, certifiers and some other products. So go into some details primarily on certifiers today, but again, I'll answer questions about anything. And why can't I advance my slide here? Let's see here. Come on. All right. It's just stuck. So let me, I'm sorry. All the preparation seems to have gone awry here. So let's try this one more time. Full screen. There we go. All right. So a little bit about Ideal Networks. So we started about 30 years ago as a company called WaveTech. So if anyone's been around for more than 15 or 20 years, you might recognize the WaveTech name. And that's where I came in to Ideal. And then Ideal Industries is a name I'm sure all of you are familiar with. So once upon a time during the mid and late 90s, when all of the merger and acquisition craziness was going on, WaveTech got bought and split by a couple of companies. So Ideal Industries bought the Certifier product line, the LAN network testers. And WaveTech also had products for fiber testing, cable TV test equipment, and electrical test equipment and calibrators. Fluke bought the calibration products and the multimeters. And I think they had a brand they called Meterman for a while, which was the WaveTech product. So that was sort of a sub brand, and I think it's since gone away. And then the calibration products, so these are products that are used to calibrate multimeters. They were bought also by Fluke, but part of their calibration group, not field instruments, but laboratory instruments. So that's
and before you go to the next bullet, Blake had mentioned that he was on Ideal Industries website, and we are actually a separate company. And Dan has what, 20 years? I've got almost 23, and I was under Ideal Industries, but a lot of you in the field might be familiar with the installation products that were under Ideal Industries, under their Datacom group, and then eventually we became a separate division and now a separate company, but we are a completely separate entity.
Yeah, totally standalone company doing network testing now.
Yep.
So 3 bullets that I want to talk about today are some standards changes that have coming out. And I think that's one of the things that led to some of this discussion here. One thing is called DCRU, which I'll explain. TCL and ELTCL. So what is it and why do you care about it? Multi-gig and N-base T, what problems did it solve and how do you support it? So these are 3 new technologies and testing methods that are now available. And then there's a Q&A section, of course, at the end. So probably should have put the slide earlier, but I'm Dan Barrera. I'm the Global Product Manager. And as Wendy said, I've been with Ideal through WaveTech for, I think, 20 or 21 years. And as far as being a product manager, part of my responsibilities are, of course, developing the products and working with our R&D group to bring those things to market. But I also represent Ideal on the TIA and ISO standards bodies. So as far as standards development goes, I'm one of those people who sits in rooms, or we used to sit in rooms and hash out what all the new standards that we're going to develop and bring to you guys are. And so the standards meetings are now virtual like everything else. And in fact, we start the next round of TIA meetings tomorrow all through next week. Then there's kind of a down week. And then we have the ISO meetings, which are all week long. So, we're doing those virtually. It's not as cool as the places. The ISO meetings are usually really fun places, all over Europe and Australia and Asia and everywhere else. Versus the TIA meetings are in places like, Las Vegas or Orlando, places where you typically have trade shows, not the most exciting places. And then Wendy Thomas is my partner in crime here, who we've worked together for quite a long time, so she can tell you about herself.
Hey, everyone. And I see Theron just got added to our list. I'm a regional sales manager, and I work with a lot of customers, all of my colleagues here in the US, and we are globally based in England. So we work with that group as well. And we work with our distributor partners like Theron's company, and really happy to be on today, Blake. As I told you earlier, I think what you're doing with this forum for contractors to meet and learn and share best practices is really a significant effort, and hopefully our products will fit right into that messaging.
Yeah, thank you.
Cool. All right. So a little line of our timeline on certifiers. So my title is Inventors of Cable Certifier. A lot of people think Fluke invented the cable certifier. That is absolutely not true. It was invented by WaveTech. The first model actually before this one in 93, which came out I think in 91, was called a TMT Pro. There's just no pictures of it that we have. So there's a little box that goes to the left of that, but then we had the Lantec 10100. And then the Lantec Pro and Pro XL. So the 10100, this did some of the tests we're used to today, but completely simple by today's standards. The Lantec Pro and Pro XL was unique because it was the first cable certifier that had dual-ended crosstalk. So any of you that have used certifiers, you know that the results you get for a lot of the RF measurements, you have the result for the near end and the far end. With the products previous to that, this one on the left here, the remote was sort of a dumb box. It was electronic, it had circuitry in it, but if you wanted to test the crosstalk on both sides of a cable, you had to physically test the cable with the main unit at one side and then go and test the cable with the units flipped around. And one test took about 3.5 minutes. So imagine, going through every cable 3.5 minutes, flipping around. So now you're in 7 minutes of testing per cable. And today, as we go through the product line here up to the Lantec 8007 and Lantec 2, 3, and 4, we're doing all that and more in 7 seconds. So testers have gotten a lot quicker, a lot more efficient, a lot more accurate. They do an insane amount of measurements. And just, I'll throw this out there real quick. I think one of the questions that we get asked a lot is, why are certifiers so expensive? So Wendy, what does a land tech 4 cost typically?
Starting point MSRP about $9,600.
Right. And people go, oh my gosh, 10 grand. I mean, I can buy a used truck for that much. The way that we design, manufacture, and what these certifiers do is it's the equivalent of a piece of laboratory gear called a vector network analyzer. The VNA is the size of like a microwave oven, big old honking microwave oven, not one of these little dorm room ones. And then there's another box under it, which is about half the size. So you have a big laboratory piece of equipment, and they cost between $90,000 and $130,000. And they'll take 30 minutes to test a link and generate all the data that a field certifier does in 7 seconds and by just pushing one button. So they're expensive because the circuitry is all custom. It's not like you can buy the parts off the shelf. It's, we're not selling 5 million of these a year like Apple's selling iPhones or anything like that. So it just makes them expensive.
Yeah. I'll just add in there, Dan, these are serviceable testers. And at our North American office in New Jersey, we get requests for service and also the annual calibration. And there are still some of those almost original units in the field, which is amazing. So well done to the contractors who are taking such good care of their equipment. We support everything as long as we can, of course, as long as components are available. But yeah, it's really, there's some antiques out there in the field, Blake, probably some of your.
Yeah, we just stopped servicing Landtech ones
a
year, maybe 2 years ago now. And we sold the last of those, more than 10 years ago. So anyhow, that they are definitely serviceable items. Real quick on standards, who are all these people? So you probably have seen some of these acronyms in your training. So the first at the top is the accrediting body. And these are international organizations that create all of the rules on how a standards group creates a standard. And you have to get the standards development organization, the ones in orange here. Those are the groups that actually write the specifications, but they do so under the rules and guidelines of either ANSI, which is the American National Standards Institute, or ISO, which is the International Organization for Standardization. Underneath that in orange, we have IEEE, which is the Institute of Electrical and Electronic Engineers, TIA, which is the Telecommunications Industry Association. So that's the one you're probably most familiar with here. We have IEC, which is an International Electrotechnical Consortium. What we do as far as cable certification is participate in TIA and IEC, and those are the standards bodies that write the standards for cabling. So we have the 568.x series. For TIA and ISO, we have the 11801.x, and there's a bunch more than just these two, but those are the ones most people are familiar with. IEEE develops Ethernet standards. So 802.3, there's us, which is the Ethernet protocol, and there's the XX because there's all kinds of variants of that. And then you probably recognize 802.11 as well. That's the IEEE standards for Wi-Fi. So 802.3 is for Ethernet, and then 802.11 is for Wi-Fi, which kind of rides on top of that a little bit. When we develop standards for cabling, the first thing that happens is IEEE will develop the specs for the protocol or the signaling. So if it's 10 meg, 100 meg, 1 gig, 10 gig, 40 gig, all of the types of Ethernet that we're familiar with, as well as other protocols besides Ethernet, but that's what we care about most. So once they develop the signaling, and this is the spec for the little Ethernet chips device called the PHY that's on all of our computers and anything that's networked. So any Ethernet enabled device, IoT device, sensor, whatever, is going to have an Ethernet PHY in there. Once those specs are written, then the cabling people, we get together and we start writing specs for the cabling that will support the electrical specs that are developed by IEEE and the 802.3x standards body. So I hope that kind of clears up a little bit of who's who in terms of all of these standards groups.
I think, Dan, with this, I always used to explain it that like the NEC, the National Electrical Code, that gets officially updated maybe every couple of years, and it's a requirement by law and tied to safety. And the standards can change, it seems, every 5 minutes, but they're more tied to performance. So from perspective, you might have to pay attention to it in a project specification. And then a lot of cases, it's tied just to the performance of whatever it is you're installing.
And there's 2 points I'll add to that. So one is, you're absolutely right that these are performance related, not life and safety. So that means they're not legally required. So anyone that, you know, holds a C7 electrical contractor license, you know, you have the electrical inspectors coming in and making sure things are safe. And that's a government organization signing off on that work to make sure nobody's going to die when they touch a light switch. All of these standards here are performance related, not life and safety. So they're not required from a legal standpoint. They are all recommendations on installing things or creating devices to get that performance that's advertised. The second point has escaped my mind. It'll probably come back to me in a minute, but I'll carry on. So if there's any questions about that, we can answer those. Cable certification tests. So at a high level, the required measurements, and there's words more than this, but these are the primary ones, are wire map and length. And that's something a verifier can do. So we talked about certifiers costing, you know, $9,000 and up. A verifier does wire map and length, and, you know, that can be had for $150, $200+. Next, Empower Some Next, Return Loss, ACRF, and ACRN. So I'm not going to talk about those. Those are things hopefully most of you have at least heard of before, but there's a lot of information out there about those measurements.
I just wanted to add there that I get a fair number of emails from customers who say, I have a job spec and these things are in it. What do I need to test it? So to Dan's point, those lower 3 measurements are specific to the certifier, all of that electrical, you know, signaling and measuring, he meant it before. That's where we're always going to take you to a certification tester, because that's what's being required.
Correct, right. If you see that any of these measurements here are required, there's nothing except a certifier that can do those. Period.
Right.
Period, end of story. And there are 4 companies in the world that make those: us, Fluke, Softing, which sells under a couple names, and AEM. So you've got 4 choices, and that's it. Optional measurements. So these are measurements that have that are in the specs but are not required for doing field certification. And someone will say, well, what's the point of it being in the spec if I don't have to test it? Well, it's in the spec for testing by a manufacturer. So when you buy a cabling system, the manufacturer needs to make sure that it's designed, manufactured, and tested to comply with these specifications, or the specifications for each of these measurements. It's not required in the field until just very recently. So DC loop resistance and resistance unbalance, those are the first 2 things I'll talk about. And then TCL and EL, TCTL, we'll talk about those second. So these are optional things that, well, I should say they were optional, but these first 2 are going to be required very shortly. And by that, I mean, those of you who are on before we really started, I mentioned that we have a TIA meeting. The meeting's starting tomorrow and going through next week. And we have a bunch of standards out to ballot or for vote. And we'll be going over the results of those starting tomorrow. And this could be, if it passed, it could be ratified in the next couple months. DCRU means DC resistance unbalance. So you might be familiar with DC resistance. That's a measurement of the number of ohms in a piece of wire or cable that is resisting the flow of electrical current. And DC is the type of power you get from a battery. And this is important because of PoE. So we all know what PoE is. Now DCRU is only required currently for category 8 certification. Everything below that, category 5E, 6, 6A, what about Cat 7 and 7A? Do those exist? That's we can cover that in Q&A. But for 5E and up, DCRU is optional. Now, that's going to be changing here very shortly because the 568.0-E, which goes back to, that's the latest version of this middle green box, is being updated to E-1. And what that's going to do is require DCRU measurements for 5E6 and 6A. And so you will need to measure those to ensure that the cabling supports PoE. And there's more than just supporting PoE, it's also ensuring that the cabling supports the data and the signal integrity of the data while it's being powered. So I'll go over some of those details, but heat is one of the side effects of PoE that can affect both data integrity and the equipment reliability of it because it generates heat. This table down below here shows, and I'm just looking away at my screen here, so this table down below here shows the different types of PoE, and it's a little confusing. The weird thing is this top blue bar, 802.3 BT type 3, also encompasses type 1 and type 2. And then there's type 4. So I wouldn't worry too much about these blue, gray, and purple boxes because most people don't refer to those out in the real world. What we're normally seeing are classes in terms of the specs on a piece of equipment. So there's 2 rows here. The first row and next to the switch is how much power is supposed to be delivered at the PoE switch or the PoE injector. And then the bottom row is how much power is expected to be available at the end of 100 meters of cabling. So you will have some loss in the cable. So for class 1 as an example, if you plugged right into the switch and you had a device that measured the power, you should have at least 4 watts. And if you go to the end of a 100-meter cable, you should have at least 3.84 watts. So anything equal to that or greater is a pass. Now, how would you test that? You would go back to this little family of testers here. So we have something called a PoE Pro, which is a verifier, but it puts a load on the line. And how it works is it identifies the class of the PoE switch or injector. So if you're not aware, a PoE switch isn't always just putting out power on the line, because a lot of people might go, oh my gosh, you know, what happens if I plug my laptop into a PoE switch? Is it going to fry the Ethernet port? And no, power is available on demand. So when you plug a device in, that device, there's a negotiation process that happens and it says, I need power. The switch says, I can give you this much because I'm a certain class. And then the device will take you know, what's allotted within that class. So the PoE Pro tester will detect what class the switch is, and then it will put a load on that line and try to get at least what's shown on the bottom here. That's at a minimum. And ideally, if the cable is good enough or short enough and, you know, made of nice large gauge wire, you'll get something closer to the top row. So you can see in class 1, you only lose about 150 milliwatts over 100 meters of cable. As you deliver more and more power, the resistance increases. So when you go up to class 8, which is 90 watts, you're losing almost 20 watts of power. So pop quiz is what happens when you lose this power? That's a loss of efficiency. So I know you can all answer the question, but I hear everybody shouting heat, heat, right? So this is dissipating, that's the other word we use, is dissipating 20 watts of heat in the cable, up to 20 watts. And these other classes can be less. So if you have a bundle of cable and they're all under full load, then each of those cables is dissipating 20 watts of heat. Now, if it's a long cable, that is going to be, that 20 watts is over the length of the cable, so it might not get too hot in any one spot. But if it's a short cable, that 20 watts. So imagine putting your hand on a 25 watt bulb. It's going to burn you if you keep it there long enough. So I'll get into why that's a problem, other than burning your fingers. PoE implementation. So just as a refresher, power is applied. It's DC current. It can be applied to 2 or 4 pairs. And actually we have some new specs for a single pair Ethernet where you can use 1 pair even. It's not called PoE anymore in that case, but anyhow, typically your blue or your orange and your green pairs are going to be the primary 2. And that's where it goes back to the different types of PoEs. But you can have 2 pairs or 4 pairs. Now, the thing to keep in mind here, or to look carefully, is that both conductors in a pair are either positive or negative. A question that we get asked a lot is, how can you put power over the data? Doesn't it screw with the data? And the answer is no, as long as both conductors are the same charge and have the same voltage. And that will get into some of the other things we'll talk about with the TCO measurements.
Dan, you have a question.
Okay.
From Matthew, who right away answered heat. He knew that. And then he's asking, what happens when you have a bundle of Cat 8 cables? Is the heat a problem?
So that's a good question. And shielded cable is considered a mitigating effect for PoE heat because the metallic foil and the braid will help dissipate that heat more easily than it will with unshielded cabling. So if the question is what happens, nothing particularly bad happens, but what happens that's good is that cable is easier. It can more easily dissipate its heat into the air, keeping the cable itself cooler. Great question. Okay. So if we have balanced conductors, this is what an ideal PoE situation looks like. So at the top here, these are just some, in the blue boxes are some numbers for the limits in terms of how much resistance you can have. And there's 3 measurements that we do. And I was going to sketch those out real quick. So let me really quickly. And Blake, how much time do we have? I don't know if I need to pick it up or not.
Yeah, you're 30 minutes in.
Okay.
Yeah, we have 90 minutes blocked off.
Okay.
So you're pretty good right now.
I'm good. Okay. So just real quickly, I'm going to change over to this iPad here. And okay. So if we have a pair of wires, and now I'm drawing with my iPad and my pencil, so excuse the chicken scratch. And one of these is striped, one solid, as would be usual. So there's 3 measurements we do. We have loop resistance. We have pair to pair resistance imbalance, and we have intra-pair. So loop resistance, the first one, is where the tester measures the resistance going in one conductor of that pair. At the other end, it gets looped around, as the name implies, and we measure the resistance of that pair of wires in a loop. Okay. The other one is let's do, so this is loop resistance. we'll do intra-pair, and I'll just call it IP, not to be confused with Ethernet IP. What we do here is we measure the resistance of each conductor. So we measure it here, and we measure it here, and we get a number for that first conductor. And then we measure the second one separately, and we get a measure for that conductor. So the first one is the sum resistance of both conductors. The second one is the resistance of each conductor individually. The third one, so now we need, where'd it go? Not that one. Where's the drawing I just had open? I lost it. I have to do it. I'm not going to do the whole thing from scratch. So we have, let's say, a blue pair, and we have a green pair. Now we do this with all 4 pairs. And now this is the pair-to-pair resistance unbalance. So we tie them together, and we measure the parallel resistance of that pair of conductors, and we compare it to the parallel resistance of that pair. And then, of course, we do it for all 4 pairs. And we're making sure that the difference between the minimum, the highest and lowest values of all of those is within some specification, which is shown on the PowerPoint that I'll go back to here. So
Dan, some of this is inherent to the product itself, right? So the manufacturers have designed their cable to be able to support levels.
yes.
And some of it is also dependent on the installation itself.
Yes. There are a couple things you might notice. So generally speaking, the wire gauge, well, I'll say this, if you're looking at cable, you might see a lot of vendors with Cat5 cable coming out with like a Cat5 PoE grade cable, Cat5e PoE. The difference between that and your Cat6 and your 6A is that the conductors are upsized. So normally Cat5e is a 24 gauge conductor. Cat6 tends to be 23, Cat6A 22 or 22.5 gauge, fatter wires as you go up. The normal 24 gauge Cat5e is not the greatest for PoE, so manufacturers have most of the premium ones are offering a PoE compliant Cat5e cable. So yes, that's choosing your components, choosing your cable. The worst thing you can do is choose a cable called CCA. Anyone know what CCA means? Wendy?
You want to make copper aluminum?
Copper clad aluminum. When you buy cable, right? When you buy real cheap cable on Amazon or eBay or whatever, pay special attention that it's not CCA and that it says 100% copper, something like that. If you're buying, on the internet, to keep the costs down, the wire itself is aluminum, and then they put a little covering of copper over it, and it's very, very poor for supporting PoE. The installation is the other part of it. So one of the things, if you don't terminate the cable very well, you don't get a good, nice punch down on it, you could have a high resistance contact, which would lead to resistance unbalance. So going back to the top box here, we have loop resistance. We're allowed to have 25 ohms. So that's the resistance of this wire down and back. The unbalance within a pair. So if we measure conductor 1 and measure conductor 2 separately, the difference can be only 0.2 ohms. And then if we measure the difference between the orange and the green pair, for example, the difference between those can be only 0.2 ohms as well. So those are what the tester measures and checks against when it does a resistance unbalance test. So in this example here, we have all greens. So on the orange pair, I have, and I just put these numbers up arbitrarily, we have 12 ohms on the first conductor, 12.1 on the second. So the total of those is going to be 24.1 ohms. So that's less than 25, check. If we add these up, that's less than 25, check, 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 okay? This is like my results table here from our tester. So loop resistance, we're allowed 25. The highest loop resistance was 24.25, which is the brown pair. So that passes. Pair unbalance, the resistance unbalance within a pair is allowed to be 0.2 ohms. And the 3-6 pair in green, we have a difference of 0.18 ohms. So that's good. And the difference between the pairs is also allowed to be 0.2. And between the 3-6 and the 4-5, if we add those and then calculate the difference, it's 0.18 ohms, so that passes. So this cable would pass resistance unbalance with your certifier. And that means it will support all the way up to 90 watts of PoE without these issues that I was alluding to. Now, can every certifier perform a resistance unbalance test? No. And this is not something you can do with a software update because it is hardware that's doing these measurements. So if you have basically for us, our Landtech 4 does resistance unbalance and the older certifiers don't do it. For some other vendors, it's basically only the newest, very newest models that will do resistance unbalance. Now our Landtech 3, because we have a lot of them out there and we love our customers so much, we actually are making resistance unbalance test heads that you can use on that previous generation tester to perform these measurements. And so those will be available in the next several months. That's a significant outlay if all of a sudden you have to start testing 5E, 6, and 6A cable and you don't have the capability to do this measurement, which again, used to be optional, but it's going to be required as soon as this new version of the standard of the 568 document is ratified.
So Dan, then there's a front end application where you're doing your baseline certification and testing per requirements to have, that reporting in your files, but then there's also a troubleshooting side to this, right? A diagnostic side, because you might get that call as the person who installed the cable that PoE devices are shutting off or whatever or there's too much heat. And this would be a way to identify that.
This would be a way to rule out the cabling as the source of that problem. Yeah,
right.
Exactly.
Right. Okay.
Now, if your resistance is unbalanced, you can have problems. So in the first one, our total loop resistance is good, but we can see that the 3-6 pair is too high. That's 25.2. So that failed the loop resistance measurement. The pair unbalance is the 4-5 pair. So we have 12.0 and 12.6, and that difference is 0.65, which is greater than the 0.2. And then the last one, the pair to pair, the 1, 2, and the 4, 5. So the orange and the blue, the difference between those is 0.550 ohms. So this is a pretty gnarly cable where it fails all three of those. Now I'm going to switch slides.
Is there a fix for that, Dan, or are you screwed if that's?
Well, there is. So you asked the question about, give me one second. You asked the question, where is this? There it is. About materials or workmanship. And yes, the first fix, if you fail one of these, the first fix is going to be to re-terminate any of these that fail. And this happens to me. So when I'm working here at home, I've got all these bundles of cable that I'm doing different measurements on, and I have them all coiled up with Velcro. And it's funny because only when we started doing resistance unbalance measurements, some of my cable spools were failing, and they were failing resistance unbalance. And it's because as I'm working with them and putting them away and taking them out, I'm twisting the connectors at the end, and the pins on some of those connectors are just wiggling out. They're still making contact. Like it'll pass crosstalk, pass return loss, pass wire map, passes everything, but resistance unbalance fails because that wire, one of those wires just worked its way up a teeny tiny bit. So here's the Lantec 4 sitting on my desk here, and I did some measurements earlier. So I'm going to go in and let me zoom in a little bit for you guys. Okay, and we have a job here called LVN1. And let's look at some of the tests. So here's some failed ones. So this is a Cat 5e, and you see the standard, let me focus that, says Cat 5e plus PoE. So what we've done is the hardware in this tester can do resistance and balance. And now we, in this new software, and this is beta software right now, so there actually is a bug here, but it will let me measure with this new Cat 5e plus PoE. We have a Cat 6 and a Cat 6a plus PoE. So essentially this takes the existing 5e 6a measurements and adds the PoE requirement to those. So we see we have a fail here. I can see all my RF tests pass, okay? But I have a fail in the low frequency. Okay, so my loop resistance, DCLR, DC loop resistance, has failed. And so we can see here, the resistance is over as 21 ohms, and I have a typo in my presentation because it should be 21 is the limit, not 25. I think that 25 came out of my head from a really old spec, so apologize for that. But we can see here 3 of these are too high. The loop resistance is too high. Now, let's go back and look at the other measurements. Now here's the bug I mentioned. Is it in this one? Again, this is beta software. So this is the pair to pair. So this is the resistance between pairs. So 1, 2 to 3, 6, etc. We could see here, these bottom 2 have a negative margin. They actually this one too. So 1, 2, 3 of these have a negative margin, which failed. So that should be an X there. And that's just something this beta software isn't catching. So no big deal. And then the resistance for within the pair, these are all good. So we can see the resistance within the pair is good. So this cable fails the resistance unbalance PoE test. Now, how long is this cable? Because, you know, if it's that loop resistance should support 100 meters, which is 328 feet. You can see this cable is only 60 meters, about 180 feet. And it's already failing the resistance. It's only going to get worse if this cable gets longer. Wendy, what kind of cable do you think this is?
It's not the CCA, is it?
It is CCA. This is copper clad aluminum cable.
LVN would never that cable.
I'd never use that, no.
Never.
So it's a
dirty word in LVN. Don't ever say that.
I'm glad.
Exactly.
Yes.
Zip ties and CCA, those are bad words.
Right, yeah. Bad.
So if you didn't do this resistance unbalance measurement, you wouldn't know, right? Because all of the, if I go back, all of the RF parameters, next, return loss, insertion loss, power sum, ECR, blah, 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 those all pass, okay? So from a RF performance standpoint, this cable will pass, it's a Cat 6 cable, it'll pass 1 gig, it might even pass 2.5 or 5 gig, but it's going to cause problems with resistance unbalance. So if I go back to the slides here, okay. The primary things that are going to happen are heat buildup within the cable. So when you have this imbalance, you have uneven amounts of current going from between one conductor and the other. So that can generate heat in the cable, but it also generates heat in your equipment. So your switches and your, if you're using mid-span PoE injectors, those will get hot because it's trying to force uneven amounts of current through either a pair or between pairs. Because remember, if it's a 4-pair, 2 of these pairs are tied together. So it will generate heat, and that does 2 things. So one is the heat in the equipment can basically shorten the service life of it. Electronics don't like heat. The other thing is the heat in the cable. So if you're running this under high load, high PoE load, the cable will get warm and the insertion loss or the attenuation will increase. So insertion loss is the measure of signal loss along the cable. And that is a function of frequency and temperature. So as temperature goes up, the insertion loss increases. So if you have a long, let's say it's, well, this is a 60 meter cable, and the insertion loss, and that's actually, so look at my, well, you can't say I don't want to switch screens again, but my margin, well, I'll do it. I want you guys to see this with your own eyes. So you can see the insertion loss margin right here is only 0.7 dB on a 60 meter cable. So there, it will pass data right now, but if this cable were, you know, any longer, it would actually fail the insertion loss test. But right now, you'd look at that and go, oh, it's fine, it'll pass data. But if this cable gets hot, if it's installed in Phoenix above a ceiling and it's the middle of summer, the temperature that the cables are rated to is 60 degrees C, which is like 130 something. So if it gets any hotter than that, the insertion loss is going to increase over the limit, and then you might start getting data or transmission failures on that cable. So yes, CCA is bad news. Let me go back to the PowerPoint. Okay, so.
You're just over halfway time-wise, Dan.
So what causes DCRU? Excessive loop resistance. So cabling greater than 100 meters, good cable, especially if it's 24 gauge, copper clad aluminum cable, poor terminations, incomplete punch downs. If it's excessive resistance within a pair, that's usually poor punch downs. So, you know, using this, you can see if your loop resistance failed, it could be any of these three. If the resistance within the pair failed, it could be a poor termination. If the pair-to-pair fails, it could be both the cable is long, because some pairs will be twisted more tightly than others, and that creates an imbalance between them. Or another thing is if you have old Cat5 cable where the brown pair is really loosely twisted and the orange pair is quite tight, you can get an imbalance there as well. So those are the primary.
So I could see an application here where you're not installing the cable, but you've been asked to put the PoE devices on the existing cabling. And you're like, wait a minute, I'm not putting cameras or wireless access, whatever it is, until I know what's in the wall, because it could be any of these things, and who knows how old it is. So that would be a really good application to.
Exactly. And so the ways you can test this are, of course, with a certifier to test the cable itself. The other way to test it from a practical standpoint is going back to this PoE Pro tester, which, Wendy, is 300 and no, how much is the PoE Pro?
Oh, it's $475.
Yeah. Okay. So for less than $500, this tester, if the network is live, if you have your PoE switch in place, you could just plug it in at the far end of the cable, and it's going to do that load test. It's going to tell me, am I getting, for the particular type of switch I have, do I have enough power getting to the other end? So if I plug it in at the switch, let's say it's a class 6 switch, those are pretty common these days. 60 watts. If I plug that tester into the switch and I get 60 watts, then I go, okay, the switch is providing the power it should. If I go to the end of my cable and I'm getting less than 51 watts and it fails, then that tells me something in the middle is a problem, probably the cable. So that's a practical way to check and make sure that your cabling and your switches and everything will support.
So Raymond had mentioned early on that you have an ideal like wire map level tester that all the features of that type tester, Raymond, and then it adds in this PoE testing that Dan just mentioned.
Yes.
Yeah. It's kind of
benefits, I think we've covered the benefits of doing this. How do you do it? So like I said, we'll have a software update where we will add a plus PoE notation. So this is a screenshot for ISO tests, but we'll have plus PoE. We also do something called max in our tester where it does all the measurements, all those optional ones. So back on this slide.
Just real quick, there is a hand raise. I don't know if it's too late, if it's already been answered.
These optional measurements are all done when you select the max setting in the tester. As the name applies, it's going to test everything. Okay, so what's the question we have?
There is Brian. I unmuted you. Did you have a question?
Okay. I see
He's-
somebody's. He looks
he's
like he's still
unmuted.
muted. He might have to unmute himself.
Yeah, he raised his hand, but I don't know if he has a
All right.
question or not.
If it comes back up,
we
we'll
continue.
take that. So questions on DCRU? Well, if oh, I thought I heard somebody. Okay. Feel free to ask questions on that topic, even though we're into the next thing now. So TCL and ELTCL. This is another measurement of balance, except it's RF balance. So the first one is DC balance, and this is a measure of how well the conductors in a pair are balanced from an RF standpoint. So it's essential for optimal performance in noisy environments, so especially in industrial factories and places like that, anywhere where you're running cable near sources of EMI or RFI. So it ensures that external noise is equal on both conductors. It's required for Cat 8 only, though there are specs for 5E through 6A. So as I mentioned earlier, we have specs that are optional for field testing, but the cabling has to meet those requirements from a manufacturing standpoint, but it's only required to be field tested for Cat 8. So if you're doing 5E through 6, you can run this measurement using the max setting in the tester. So if you choose max, it will also measure this TCL and ELTCL. So what the heck does it mean? Did I define that here? No. TCL is transverse conversion loss. ELTCL is equal level transverse conversion transfer loss. Equal level transverse conversion transfer loss. So that is a fancy way of measuring, again, the RF balance on a pair of conductors. So on the top one here on this green pair, we have a balanced pair with no noise on the system. So you guys might be aware that on a pair of wires, we have a plus and a negative voltage. It's not 1 volt. I'm just using that for easy reference. So let's pretend it's +1 on the solid, -1 on the green. Now the receiver, so that's the transmit side. The receiver is called a differential mode receiver, so differential signaling. It doesn't add the voltages together, because if I add these two together, that's like noise cancellation, and +1 plus -1 equals 0. We don't want 0 volts. That would negate our signal. But I think that's a common misunderstanding, because like noise canceling headphones, we know they add signals together that are equal and opposite to get rid of noise. That's not what's happening here. But if we take +1 minus the differential signal, means the difference of, so +1 minus -1 gives you 2 volts. So that's what we get out the other end. If we have a balanced pair with noise, so let's say this cable is running next to some source of noise, a little lightning bolt, and it's injecting +1 volts on both conductors. So both of those conductors at that point where it crosses that noise source are picking up 1 volt in the positive direction. So if we do the math here, +1 and the noise voltage is in red, +1 plus 1, that's 2, minus a -1 plus 1, that's -1. So that gives you your 2 volts. So the twisting doesn't reject noise. A common misperception is that the twisting of the cable is there to reject the noise from getting into it. It's the total opposite. We twist it because we want the noise to come in, but we want it to be the same on both conductors. And when it's the same on both conductors, the electronics can do their magic and essentially subtract out that noise. Now, what happens if we have an unbalanced pair with no noise? So an example of this would be if you take a pair of conductors and you kink it, you'll notice that one wire the pairs are gonna split apart from each other. So that's an extreme example, but let's say you have some sort of discontinuity in the cable where the pairs are separated, and this solid conductor is closer to the noise than the striped one, so it picks up 1 volt, but because they're not balanced, the other conductor doesn't pick up anything, so it's just getting noise on the solid, not the striped. Well, if we do the math over here, at the end result of that is our signal is now only 1 volt instead of 2 volts, so it will cause a decrease in the signal voltage, which means data errors, frame errors. So that's what TCL is. So what we do is with the tester is we measure the RF balance. We measure how well, that's literally what it is. It's an electrical measurement of how well the conductors are twisted to each other, within that pair. So we have a crosstalk measurement, which measures interference between pairs, but TCL and ELTCL is measuring the balance within a pair. And the difference between those two measurements is TCL is measuring, it's transmitting on the solid on this end and receiving on the striped on that end. ELTCTL simply means that it's transmitting on the conductor at one end and then receiving on the other conductor at the other end. That's all it means, is one is done at both ends of the cable, and the other measurement is done at opposite ends of the cable. So it's a kind of very propeller head topic. I'm hoping that kind of brought it down to where you can understand what it means. And how it matters is, again, if you run these measurements and it fails, that will tell you that cable might perform adversely when it has EMI or RFI conditions around it. Now, what if you measure, what if you do a certification test and you didn't run the TCL measurement, and later on the network's running or something, and there's questions about they're having data failures or low bandwidth, and you think it might be that type of issue. Well, fortunately with the LANTech 4, we always, whether you select them or not, just going back, whether you select them or not, we do all of these measurements all the time anyways. And so they're always stored at the tester. So if you you do an installation and you've tested it with the LANTech 4 last year, and someone wants to know, hey, I hear this new DC unbalanced spec is out. How do we know if our cable's good? Well, the cable has already been tested, even if you didn't do it. You just go into our software and you use an option called recertification. And that data was captured when you do the measurement. And all we're going to do now is when you recertify, we're just going to turn it on and say, okay, now let's check to see if that measurement is good or bad. So you can actually go back to measurements that were performed where maybe you didn't have the right standard selected, or you didn't realize that you should be testing this, or whatever the case is. You can go back and recertify the cabling to those with those specs. Any questions? Okay. So a question about TCL. So next slide. What's the deal with multi-gig? That's my Seinfeld impersonation. Anyone heard of multi-gig or N-base T? Oh, I forgot to have a little copyright strike. All right, little afternoon humor. Next slide. Okay, so what is multi-gig N-base T? I'm not going to go too much into the details, but I know this is a really cool drawing that's on the Wikipedia site for this. This gives you a visual representation of bandwidth, essentially. So the more area in this drawing, the more bandwidth you have. And if you look at this little orange box, that's 10 base T. 100 base T is this yellow box. And then you get into 1 gig, 2.5, and et cetera. So multi-gig it consists of switches and network interface cards that can operate at a data rate between 1 gig and 10 gig. So we have Cat5e for 1 gig minimum. And then for 10 gig, you need Cat6. Really, you should do Cat6a. You can use Cat6 at shorter distances, but this, preferably 6a. But the equipment, a multi-gig or an N-base T switch, and the reason there's two names is there were two sort of competing groups developing these specs, and they've eventually merged them together. So the names are used kind of interchangeably. But what it will do is, if your cabling is good enough, let's say it's a 5e cabling, if it's good enough, you can put this equipment on and actually get 2.5 or 5 gigabits of bandwidth on that existing installed cabling. So it extends the life of a cabling plant by letting you swap out equipment and run data rates that are higher, faster than that cabling was originally designed for. So you can get up to 10 gig or 10 times more than 1 gig. So
Go back 1 second, Dan. I think that visual is good because on the left with your categories, that's your physical infrastructure TIA certification. And on the right with your Ethernet speeds is your IEEE application, the actual data that's going to be traveling down the cable. So it's yeah, touching on the standards.
Excellent point. Yeah, so these numbers here are TIA or ISO cabling specs, and these numbers here are the IEEE Ethernet specs. So you can see how they all play together. Good catch, Wendy. That's an excellent observation. And we have the frequencies here. So 5E is equivalent to 100 meg, 6 is equivalent to 250, and so on. Now, 10 gig only operates at 400 megahertz, although we test Cat6a up to 500 megahertz. Since Cat5e, on the cabling standards, we've always measured the cable at 25% higher frequency than the data, than the IEEE spec. So for example, 1000 base T operates at 80 megahertz, but we still test it on Cat5e to 100 megahertz. So we've always added like a 25% margin buffer in there in testing applications, just to make sure that you're not right at the limit of a cable just barely passing, and then just one little step more makes it fail. This is a little more simplified version of that chart. So this just shows your, and actually 1 gig should be on here. All of these will support 1 gig, but 2.5 gig, and this is a should box. So 5e should support 2.5 gig. Cat6 should support it, and Cat6a certainly will. 5 gig, Cat5e, don't know. Cat6 should, and Cat6a will. And then 10 gig, don't know, supports it. So how do you answer the question about these don't knows? So that's where a different type of tester can be used, something called a transmission tester. So where a certifier operates by testing the electrical parameters of cabling and making sure that it meets those TIA or ISO specs for that different category, a transmission tester is a product that shoots data down the line and measures packet loss or frame loss. So it will actually go through a cable. So you can use it to test a piece of cable, or you can actually go through your active switch and run it through your network and see if it's the cable dropping frames or if the network is dropping frames. Now, that's a brand new product. We are just launching it. And I was supposed to have one here to show you guys in person, but it didn't make it here. It's still with UPS. So we do have a virtual demo that is like kind of an interactive PowerPoint thing. So I think Wendy wants to show you guys a couple slides from there just to give you an idea of what type of information a transmission tester will tell you. So that's called the Signaltech 10G. It looks like a Lantec. It's just a little beefier. It's got cooling fans in it because it generates a lot of heat. But this is an example of one of the screenshots. So it tells you our link speed, but how much usable bandwidth we're getting and how much network overhead here. So just because you're transmitting at 10 gig, it doesn't mean you're actually getting 10 gig of usable data. You might be getting less than that. In this case, more than 2 gigabits is network overhead. So you want to take it over?
And I know this past year that there were a lot of projects in schools, partly because they were closed with COVID, but also because of COVID, they needed to bump up their bandwidth. And the reason the tester didn't arrive yet with Dan is a school was trying it out for us, and they are using it to look at their existing infrastructure to see where they can upgrade the bandwidth, basically, just with all of the streaming that they're doing and devices that they're adding. And they really wanted to see, can we add switches here, or do we need to call a contractor and get some new Cat6 or 6A cabling put in? Unfortunately, they didn't quite get it to us in time. So
that's okay. It would just require me taking up even more time and running over. So are you sharing now?
I'm going to try. See if it'll let me do this.
Yep.
Okay, so presentation mode. There we go. Okay, still see that screen?
Yep.
Okay. Get rid of this. Okay, so as Dan said, it's in the Land Tech 4 form factor. It is 2 units. They're active devices. They are transmitting. So this is not at all the type of measurement that a certifier does. These type testers, they don't really care what category it is. They want to know, look, this is real world. I need to know what your actual Ethernet throughput is. So your home screen on the tester has some basic options. As a help screen, if you've never used the tester and you want to set up a new job or create tests within that job, there's a settings wheel that allows you to put in all sorts of information, like the operators that are going to use the tester, the preferences you want in each auto test mode, to check information on the unit, etc. And I don't know if Dan mentioned this, but this has been a good collaborative thing with our new certifier, in that in the settings screen, you can actually, there we go, put the tester in remote control mode, and someone can set up TeamViewer and remote into your tester. So there might or might not be a person with the physical tester in the field, but a project manager or another technician or an IT administrator or Ideal Networks can look into the tester, actually operate it, and see what's going on, help interpret the data, which is great. But just to give you an example of some of the different type of tests. So again, this is not a certifier. And in the screenshot we're looking at here, our 2 units are hooked up with a network in between. I don't know if this is one switch or multiple. I've got copper on one end, and this is a 5G connection that it sees. And on this side, I've got fiber, and that's a 10 gig connection. I've got a green received power here. There's an SFP that's been popped into the remote unit, and that power indicator would be green, yellow, or red, indicating whether that level of power is acceptable or not. And on this side with the display handset, because we are connected to an active port, again, where a certifier is physical layer only, cable only, infrastructure only, this is looking at network and devices as well. So it's going to tell us that I see PoE. And if you remember anything from Dan's charts, that would probably be a class 4 switch or device setting there. There's your voltage. Here's your switch detail, and you can go in and do some more network tests. What I'm going to do is click on the Analyze screen, which rolls out and shows me all the different tests that I could go in and choose. Everything from a physical layer wire map, because you might still need to check that, the PoE load that Dan was talking about earlier. I can go in and leave the standard setting on so that it will test and look for the 3 different standards or the 9 different classes. And once I've run the test, which just takes a split second, it's going to show me in this case, yep, it was class 4 and I passed because I met the minimum power. I can do a step up to see if there is additional power available from that switch. So very helpful information, and that is savable. I can retest it as well. I'm going to go back to that Analyze screen, and there again are assortment of functions. There are, depending on the model you get, copper, PoE, network functions, and fiber. So you might just be doing something as simple as seeing if you can get to the internet or if you're connected to a monitor or a camera. But I think 2 of the key functions that are going to be used to really help what Dan was addressing as far as will my existing infrastructure support a switch upgrade, or can I throw more cameras on it, is going to be using this max throughput mode. So again, there are settings And this is not showing you all of the screens, but just to give you an idea, you can go in and set all sorts of parameters here as far as the speed and your limits and the fill. And when you're done, you can save it. And then you can look at your results here with this bar graph, or you can flip to more of a table view and get detail. And this can run for any amount of time, for as short as a few seconds to several hours if you like. And this is going to tell you your actual available bandwidth. So that's not necessarily going to be the same as maybe the category rating and what it's supposed to support, or what you think you might. And this could be affected by all those things that Dan was talking about, length and termination, and if it's near something that's generating noise on the cable. So
one thing to never trust are the link LEDs on your switches. And I know there are older, like the validator qualification type testers that literally just said, use the link LED on a switch, that if it was, if it came up and linked at a gig, that, that called it a pass. And the difference between linking and transmitting data are two completely different things. A link light to come on, all that means is the switch is communicating with a device and says, I can do 1 gig or 2.5 or 5, can you? And they agree on the speed and they say, yeah, I can do it. And it's just little messages. It's not a stream of data. So we use something called, it's a half-back step or something like that. So we try 10 gig. And if that doesn't work, we fall back to a lower speed. We might transmit at 6 gig. And if that works, we'll go up to 9 gig. And if that doesn't work, we'll go down to 7. And then we kind of narrow in, zero in, and get right to the true data rate that you can get without dropping frames. So
yeah,
is that
that's a good point, Dan. And that brings us to another really key test that this can do, which is the uptime. Because if you're not getting the throughput, this uptime mode will let you again set some parameters and then monitor for a period of time. And you can look at all the data that's going on again during this transmission.
Does it tell you if you have a problem when that occurred?
Yes. So if we look at our actual bar graph here, I can flip this to a table view again, where you can look at, is my link up, is my link down? And you'll note that this is a date and time stamp. And here we've been running for 14 minutes in this mode. But the idea with this was to let her run. Maybe you want to do this overnight or over the weekend and come back and look and, is it every 6 hours? Is it random?
I have a story that I love to share with when we're talking about things like this from an old rep. And he was in Boston and he was dealing with a customer, and every 12 hours, they would all of a sudden start to get a lot of problems with their network. Now, this was 20 something years ago and these type of testers didn't exist, but he did a bunch of measurements and discovered it was related because this place was near the shore on, it didn't have a good ground system installed. So what has happened, when the tide would rise, all that salt water would flood in and they would get a nice good building ground. And then it was on rock and stuff that drained out. So when the tide would go out, the grounding system would not work as well. So they would get all these data errors. Every 12 hours, they'd see these cycles. And he saw this pattern, and the guy was a sailor and he was an amateur sailor. He's like, that looks like tidal records. And he took that data and overmapped it with the tide charts. And sure enough, bing, 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 there's your problem. So if you know there's problems and you know when they happened, you can come to conclusions like that.
Yeah, exactly. And the one last thing I wanted to show on here, because so many people are installing cameras and they're such huge bandwidth hogs. And then Dan, we're getting down to our last 12 or so minutes, so we'll wrap up. But
and I just have Q&A after this. So
yeah, exactly. So, but again, this tester has a lot of kind of discovery diagnostic abilities, and one of them is to be able to actually create traffic and send it across either a cable or through switches and really stress test. So, if you're an installer and you're being asked to add a bunch more cameras to a network or change settings on them, you might want to do this test first and really let your customer know, no, this is going to cause errors. I can prove it to you. So you can run that test again for any length of time. It'll show what your transmission rate was, and if you had any errors, and give you a lot of detail down to things like jitter and propagation delay. So really comprehensive information. And just like with the certifier, the tester is smart. It knows once you've chosen and told it what to do, the tester will then provide you the information. So, because I mean, all the stuff that Dan was talking about with the electrical signaling, that just makes my head spin. But thank goodness I can find it in the tester and say, okay, this is what I need. And then the tester tells you the rest. So.
Okay, so I think that wraps up. I don't know if you're seeing my screen, but I should be sharing a big slide that says Q&A. So more questions. I do have some questions that we seeded in case there aren't any that come up. I have a few questions I can ask. So any hands raised? Let's see.
I don't see any hands raised.
See any. And again, I just wanted to point out, having been doing this for a really long time, selling testers, customers come to me and don't know what they need. And that's our job. But this kind of information is what we use to figure out the right solution. And I've always said this, if you say, I need a Cat 5 tester, that could be $100 wire mapper. And if that's what you need, that's what we'll sell you. But if you start getting into some more detail and we find out, no, you've got next requirements and power sum, or you're talking IEEE, we're going to figure out what you need so that you're not wasting time and you have the documentation that you need. So that is our job. We welcome those questions. I'm constantly learning from our customers, which is why I've been enjoying the Low Voltage Nation site, because it's just real world, and it's, people are sharing stuff that's relevant and happening in the field. And I hope we see lots of blue testers out there, because that will certainly help our R&D team as we see how they're actually being used. So anyway. Yeah,
we've got a lot of structured cabling people in LVN. So in my opinion, I think most of them should be using a certifier on some level. So
yeah. And we have a question from, I think we had a lot of Matthews on today. So let's see. Okay.
Oh, reporting. Oh, what happened to Cat 7? Okay, so there's this, I have a slide there. What happened to Cat 7? Cat 7 exists, sort of, in the ISO standards. So in TIA, we skipped over it, and it's really a highly political issue. People didn't want to move away from the RJ45. So with Cat 7, it does exist in ISO. It's called, they use a different naming system. They call it a class, and then there's C, D, E, F, and et cetera. So Cat 7 is class F in ISO, and they actually have Cat 7A, which is class FA. And those operate at 600 megahertz and 1000 megahertz respectively. So it does exist. So there's Cat 7 components. But there are in the TIA, there's no Cat 7 test you can run. So you would use a class F or a class FA, and those are not RJ45 connectors. So there's connectors, and actually I'm going to grab some adapters to show you guys what these different connectors are.
While he's doing that, I'll answer the question about reporting. Let me look at it again, make sure I address it correctly. So yes, I would say that there is definitely a reporting requirement that's very common, Matthew. Sometimes that report is tied to getting paid on a project if they need those reports turned in for a manufacturer warranty. And if it's a commercial project, government project, that's going to be specified out how they need it to be tested. Another application, obviously, is just to have it for someone's files, whether it's the actual IT administrator at a company that's doing the testing, or it's a contractor, installer, or integrator, just having that baseline information once you've installed cable or actual, devices and a whole network. I think I saw, was it on one of your meetups, Blake, where you guys built up a whole 14 port, cabinet, network, switches, devices, the whole bit. So yeah, in that case, then I'm assuming you'd want to test everything and make sure that was documented. But
let's see.
we have a number of testers that report, but they're not all certifiers. So we can help you figure that out if you ask that question. And certifiers require proprietary software
Yeah.
or a cloud to format the raw data, because it's all that plotted electrical jumbo, but everything else, it can be a PDF.
Yeah, so the certifier, you can upload the results to the cloud directly from the tester with Wi-Fi, or there's a desktop software available too. So everything's there, and you can set up projects and download them from the cloud to the tester. It's hard to see, but this is called a Terra adapter, and this one is one of the Cat 7. You can also use it for when we talk about Cat 8, we have Cat 8.1 and Cat 8.2. Cat 8.1 is an RJ45 connector. Cat 8.2 is a non-RJ45 connector. So this is one, and there's 4 quadrants here, and each of those is a pair, and they're isolated with a little metal grid between them, or just a metal separator. This is called an EC7. Same kind of concept. You have 4 pairs in their own little quadrant, so each pair is shielded from each other very nicely. And then the third one is called a GG45. This one's going to be really hard to see. You can't actually see. At the bottom, so instead of an RJ45 where there's 8 pins all along the bottom, this looks like an RJ45, but it has 2 pins in the bottom corner, 2 pins in this bottom corner, 2 pins in this top corner, and 2 in that top corner. So sorry, having trouble keeping it focused, but you have what looks like an RJ45, but a pair is in each corner, just creating more separation between them. So from a form factor, it's backwards compatible, but it's, these two guys here have much better isolation for crosstalk between the pairs. So this can be Cat 7 and up, or what's called Cat 8.2. So those are your options for those other types of connectors.
Yeah. I can share my screen really quickly and show a sample of the report. The cable to support what Dan was just talking about, though, is what's called like pairs in metal foil or pairs shielded. It's not just the
right. Each pair has a shield, not just a screen around the whole.
Yeah. But this is back to the transmission tester. And because this is not all that plotted electrical signaling data like a certifier, the PDF report can actually be created right in the tester itself. And then it can be copied to a thumb drive. You can view it in the tester, and it can also be synced and uploaded to the cloud where it can be viewed and or sent off in an email or even printed if somebody wants to do that. And both the SignalTech 10G and the LANTech 4 have a sync function. They work with the same cloud platform, which is really a test management system. And then some of our reporting testers don't require the software, the cloud, and they will make a PDF report or a CSV file available to you.
We have another question. What is a real world certifier? This is what the thing I was talking about, what that uses a link switch. So it used to be a company called Byte Brothers, which was bought by, it's owned by Triplet now, Triplet Testing. Yeah. So the real world certifier is a little handheld tester.
I call it the Fisher Price.
It does look like a little Fisher Price tool because it's lots of colors.
Not my favorite product. You could put that with the cable ties and the CCA.
Right, and how it works is the remote handset is you supply your own Ethernet switch. So literally, when you take the main, my camera.
You charge your camera.
It's a DLSR and the battery went dead.
Yeah.
Anyways, you don't need to see me anymore. But the remote handset is a switch. So when you do a test, all it does is it brings up the link LED on the switch at the far end. And if the link LED comes up, it says passes 1 gig. And that goes back to what I said about it's not actually transmitting data. All it's doing is looking at that switch and it says, oh, you're a 1 gig switch. And if the link light comes up, you can use the cruddiest Cat3 wire and put it between a real world certifier, and it will tell you that it passes 1 gig because it's not actually passing data. It's literally just got to turn the light on at the other end and say, okay, that link LED's up. So that's what a real world certifier is. I would, and I'm being impartial here. Like it will pass tests that you can have data failures on all day long. And your tester might say it's good when it doesn't do any sort of performance testing. Yeah.
I'm answering another question, Matthew. I'm just typing it into the chat on certification. We can certainly stay on. I just didn't want to run over our time allotment.
Yeah, we can stay on. That's fine with me.
I'll answer my next question to myself if, let's see, sharing. How do I get, where is the Zoom share? Okay. This slide here is answering a question about what's an Mptl link and versus a channel versus a horizontal. So these top two are what you're probably familiar with. You have a patch panel to a patch panel, and you use a permanent link tester or permanent link adapter. So your tester is, you have a male test lead on both ends. That's backbone cabling. Horizontal cabling, or in what's the ISO world calls a PL2, is a patch panel to a work area outlet. So this is fundamentally the same thing. It's just, where is it installed? Is it between closets or is it going to a work area? There's something called a consolidation point. So in ISO, we call that a PL3. So a consolidation point connector, that's typically used where you have modular furniture going into a building, and you can put this leg of cabling during the construction phase, either underfloor or overhead. And that's all installed, and that's the majority of the cable. And then the modular furniture goes in, and there's a consolidation point connection where then a short piece of cable is run from there to the work area outlet. There's a CP1, and this, it looks like these first two, but the consolidation point connector is at the end. So imagine that on this PL3 here, instead of testing, including that short segment, we're testing from the consolidation point back to the closet. So this would be, if you do that initial cabling during the construction phase, you can test it before all the furniture and everything goes in. And then when that last bit of cabling is installed, you can test the whole thing from end to end. And lastly, a modular plug terminated link, or Mptl. So this is where the installed cabling is terminated on one end with a modular plug. So this is mostly used for CCTV, wireless access points, terminals like point of sale terminals, sensors, IoT devices, where you don't want to have an extra connection and a patch cord and stuff up in the ceiling. So to measure this in Mptl, you use a patch cord adapter on the tester, on the remote end of your tester, which is a special adapter that can measure the mated performance of that plug. So you have the patch panel on one end, and then you're measuring the performance of the plug going into the adapter on the other end. And on here, these adapters, these patch cord adapters, are specific to Cat5e, 6, and 6a. There's actually a special connector for each of those. And they are more expensive than your regular channel adapter. The reason is that there's one company globally that makes the connectors that go in all Certifier patch cord adapters, and they hand test each of those on a network analyzer. So I started off this segment talking about a vector network analyzer. So they'll take a batch of jacks that are, they're production jacks, and hand test each one on a VNA at the time of several minutes. And if they pass that special testing, they go into bins that they sell to tester manufacturers like us for probably about 20 times the cost that you would pay for a typical jack. So instead of $3 for a 6A jack, we're probably paying 45 something dollars for that same jack because it's been hand tested to work in a patch cord adapter for a Mptl. So that's another question we get is what are these Mptls and different link models?
I honestly think we could probably spend an hour talking about that. Like it's really, really complex. Right. And as I talked to installers, they didn't even realize there were separate standards. And they're like, oh yeah, I'm putting male ends on all the time. What do you mean there's a special test? So, and there's a lot of kind of engineering behind that Dan can really speak to. So
there's some others that I didn't draw here where we have end-to-end, where you have a male on both ends, where you have essentially a very long patch cord. Those are used mostly in the industrial environments, but it's the same thing. You have to have a special adapter to measure the plug at the end. You can't just use what we call a channel adapter. So that's probably a common mistake that we see out with a lot of people wanting to test. Like Wendy said, they're not aware that you can test this configuration, but you need a special adapter to get the right measurements. I've seen many cases where a customer will unwittingly use the wrong adapter here and all their tests are failing and they don't know why. And it's just because of that reason alone. So. And I think the last question, maybe we save for a different one, which is how do I test CCTV? I don't think we have time to go into that. Yeah, it's a whole different product, but that was my last question on testing and video testing and documenting CCTV installs. So
yeah, segue from Mptl into the actual, once you've got the plug ready to go into the camera, how to use the tester to set up the camera itself. That would be good.
So that's it. I think ran over a little bit.
That's fine. That was really good. I mean, there's just so much to talk about. You guys are obviously very well versed in this subject. So I'm really excited that you guys are, in the LBN family. Such a great resource. I like the fact that you gave so much technical detail and did a deep dive. It wasn't a sales pitch. It was just like, hey, this is what we do. And I'm really excited to have you guys.
Awesome. We appreciate the opportunity.
Yeah, for sure. There is an announcement from Theron Forker. I'm sure we're gonna probably tease it later, but I just want to put it out there. We're gonna probably make some announcements on social media. But I don't know if Theron, if you wanted to talk about what we're gonna be announcing. If not, we'll blast it out on social later. Cool. All right. Does anybody else have any questions or anything? I know we're way over time, but this has been really good.
I was going to try to get my camera back up and running to wave goodbye, but it looks like it's not going to happen.
That battery's dead.
We're going to assume you have a nice adult beverage there, Dan.
Not yet, but it's the next thing in my hand.
Yeah.
That's right. Absolutely. Yeah, it's the evening time at this point.
Right. Yes.
All right. Well, that was great. Thanks you guys so much. We'll be in touch. We'll get maybe another short talk on some of these other subjects. But there's just so much to talk about, and I really appreciate it.
Yeah. Cool. Great. Yep. Thank you. Thanks for the opportunity.
Thank you so much. Yeah. Take care.
Have a good week, everyone.
Bye-bye.